So folks, if you're tuned into this video, you must have watched the other 3 in this series and you'd like a more thorough, detailed demonstration of how an engine works. So we're gonna geek out on this thing right now. But I wanna apologize in advance because honestly, I've already filmed the whole dang thing. And what I noticed is that I'm doing the classic rookie thing. And that is I keep staring at the screen of my smartphone instead of the camera lens where I'm focused right now. So I keep doing this, and it's like somebody staring at your cheek when you're trying to have a conversation, so it gets kind of irritating. So anyway, I won't do that in future videos, but I hope you enjoy. So let's pick up a few more details about this block. This is a cast iron block. Blocks are also made out of aluminum, a lot more expensive, but a lot lighter. This engine is a 4-cylinder engine, but they also make 5, 6, and 8-cylinder engines. You always hear about V8s. It's just 2 banks of 4 cylinders, kind of in a V configuration, connected to the same crankshaft. One last thing to note, these little guys right here, you see these round little things. They're plugs. They're called freeze plugs. So that's kind of what it looks like. It's just like a thin pot metal thing. I mean, it's really just very, all it really does is contains that water. What it's designed to do is if the water ever freezes inside of here, those will pop out. So really they're just kind of pressed in there, and the force of frozen water, the expansion of ice, is sufficient to force them out of those holes to keep from cracking your block. That's why we put antifreeze in a motor in a 50-50 proportion with water. Antifreeze helps lubricate inside there, all those little channels and cavities and everything, to keep everything moving quicker, but it also keeps the water from freezing. So we always hear this word displacement, and what the heck does that mean? Displacement refers to the combined total volume of all the combustion chambers added up. If you were to pour water into each one of them and then combine it all in a bucket and measure that, you can measure it either by cubic inches. So a common Ford V8 motor is typically a 302. 302 cubic inch motor is very common. If you were to convert that into liters, that would be a 5-liter motor. What you often hear is a 5.0. It's just 5 liters of combined volume of all those 8 combustion chambers. So even if you're not into hot rodding cars, still it's probably good to have some common automotive knowledge of something like stroking a motor. What is a stroker kit or a stroker motor? That's a stroked motor. What the heck is that? Well, that just means that you've added a new rotating assembly to that engine. That means the crankshaft, piston, and the connecting rod, the rotating assembly, all work in concert together. So you want them to match up, and you're going to allow that piston to travel deeper into the cylinder because there's a little bit extra room in that cylinder. Could potentially travel a little bit deeper. So when it comes from the factory, the manufacturer, when it's just a stock motor, the bottom dead center point is what we call where the piston can't go any further down into the cylinder until it starts coming back up again. We call that bottom dead center. Just like when it reaches the top around the deck of the block, we call that top dead center. Well, when it's at its bottom dead center and it comes from the factory, there is a little bit of room. You can modify the piston and make it a little bit smaller so that it actually, you can allow that bottom dead center point to be a little bit deeper in the cylinder, maybe 5/16 of an inch, or up to 3/4 of an inch, half an inch, something like that. Just, it's not much, but it's a little bit that you can capture that extra bit of displacement of volume within the combustion chamber, but you have to have a little slightly longer connecting rod and the throw of the crankshaft, all of that to work together with that piston. That's called stroking a motor. So you're taking so let's say a Ford V8 302 and you're turning it into a 331 or a 347 or a 363, depending on which stroker kit you want to get for it. Then you can also bore the, usually when somebody does that, they have the block machined again, so they take it to a machine shop and they actually bore out the cylinder and make it slightly bigger. You can't make it too much bigger before you start weakening the block, weakening the cylinders. Yeah. So how do they make a funny looking thing like this? It is an odd shaped thing. Well, they can either pour it into a mold, which is called cast, okay, either out of stainless steel or cast iron. Or they can forge the thing where they take this glowing cherry red piece of metal and with these massively powerful hydraulic presses, they force it into this shape. These little things sticking out here just help balance the thing on this side. These are called counterweights. Pay attention. This is a dipstick, and this is what you stick down in the oil pan to find out how much oil you got in there. Make sure when you pull it out, you always hold it like this, okay, with the tip down. If you don't want the oil, you want a nice accurate reading, so you don't want it dripping down this way. You want to hold it up like this in the light. Read that thing. Do it a few times. Clean it off just to make sure you got it. It's tricky reading these things sometimes, and after a while you need glasses when you hit 43. Now this is a crankshaft again, and I want to explain about oil galleys. So this is, I think, pretty cool. Okay, this thing, remember, is spinning in a ridiculous amount of times. It's revolving at a terrific rate of speed. It's literally a blur. I mean, it can spin up to 10,000 times a minute. If you consider like NASCAR Sprint Cup Series, those things are spinning 10,000. They're redlining at like 10,000 RPM. So all these journals have to get tons and tons of oil. These little holes that you see are called oil galleys. Every single one of these journals has a little hole, and it connects one to the other. Come on, get in there. And every single one gets oil. So there's oil, a whole network of channels that oil travels through the whole length of this crankshaft. Look at those things in there, how they're kind of oval shaped, okay, and they're kind of like, it's called chamfering. They're kind of ground down, filed a little bit, and countersunk, so that there's no irritation, no friction with the bearing that we're going to talk about next. When the crankshaft's spinning around in there, what are those journals in contact with? Directly with the block? Yeah. No. They're in contact with these bearings. There's a little sliver of metal inside there, and around the cap that holds the crankshaft in place is a sliver of metal. These guys are what the journal is spinning inside of. So I'm going to put the crankshaft in and you'll see. Now the connecting rod also has bearings as well. So they provide kind of a buffer for the crankshaft to spin around inside of, and they need constant oiling. And they have a hole in them as well. So the oil that comes through the journal actually gets in behind the bearing. Notice how they all have a hole in them. Bearings are very important, and they kind of tell the story. Real engine builders, they can read those things like tea leaves and tell if your engine's balanced because they'll show wear patterns and so on. All right, so now we're making power. Engine's operating properly. And what do we do with that power? We got the crankshaft spinning, so how do we utilize this power now to serve our needs? You got two ends of the crankshaft that are rotating where we can harness that energy. On this end, this is the front side of this engine, you have a crankshaft pulley or drive pulley. And this thing fits right on the crankshaft. Notice it's just going to turn with the crankshaft, and it's got these grooves. This is a serpentine belt. And this thing is going to wrap up and around the other accessories that all have their little pulleys. So it's turning the water pump, the power steering, the air conditioning, the alternator. If you're lucky enough, a supercharger. So very important drive pulley, but it also takes horsepower from your engine. But that's where at least some small percentage of the horsepower generated by your engine is going. The other end has this. This is a flex plate because this came off an automatic transmission. Flex plate or the flywheel on manual transmission cars is bolted to the other side of the crankshaft. And it spins with the crankshaft, and you'll notice it has these teeth. So the starter's bolted up under there, and the starter has a little gear. Starter's powered by the battery. So when you turn the crank of the car, you're energizing that starter. That starter has power at the ready. So as soon as you turn it over, the starter kicks out this little gear that engages that flywheel or flex plate and turns the engine a couple times. It gives it a wah, wah, wah. In the old days, they would have to get out and crank it by hand. That's a lot of stuff to move around. That whole operating assembly, plus all those valves and the whole valve train, it's a lot. So your starter is extremely important. How about a little bit more detail about this piston? This piston's got a pin right here that I mentioned before, but it's called the wrist pin. Kind of like the knee, remember, on the bicycle. And notice that the piston has these grooves around it. Well, those are for the rings. Now, I took the rings off of that piston because that was the one I used for the demonstration. And I wanted the piston to move freely up and down the cylinder, so I removed those rings to make it easier to move. But this is one of the rings. There's 3 rings that go around the piston. This is another piston I happen to have. And they just snap into these grooves. They have to be tangulated so the gaps aren't lined up. But basically, the rings are extremely important in your engine. They create a barrier between the hot gases up in the combustion chamber and keep them from getting down below where they're not wanted in the sump, down below the piston. And you don't want the oil down below the piston getting up past those rings into the combustion chamber. Then you'll have black smoke and your car will burn oil. So these slide up and down the cylinder walls. Extremely important feature of your car. This part of the piston is just called the skirt. This is the rod. The connecting rod is the weakest part of the engine. If something seizes up in there, this thing will snap. All this will become shrapnel that'll be sent all through the operating assembly and cause catastrophic engine failure. So once you get this flex plate or flywheel spinning with the crankshaft, what is this doing? It's going into the transmission, sending that power into the transmission, where it's transmitted for a rear-wheel drive car to this drive shaft, this tubular shaft, which just transfers that energy, rotating energy, all the way back to the rear end of the car, where you have a ring and pinion gear, which enable that power, that rotation, to be converted to be turned on a 90-degree angle to the axles or to one axle, and turn the wheels. Yeah. Now you might ask, well, what about a front-wheel drive car? So a front-wheel drive car, the axles are kind of connected to the transmission. The axles tie into this differential inside the transmission, and that's why they kind of call it a transaxle. So it's all combined, and that rotating energy comes out of the transmission right to the front wheels. All right, let's move on to something we didn't talk about in the first couple videos that's extremely important. I mean, every engine's got to have a brain. And this is the brain right here. It's called the camshaft. Now, the camshaft is performing a very important function, okay? It's determining the character of the motor because it's the one controlling the opening and closing of those all-important exhaust and intake valves. So when they open, how high the lift, how far they open from the seat, okay, it's called the lift. How long they stay open, it's called the duration. The separation between when one opens and shuts and when the other opens and shuts, all that determines the character of the engine. When you consider they're going so fast, what determines all that is the camshaft. Now the camshaft has these lobes around it, or cams. So they're kind of funny oblong shape looking things. And see that, those cams? Now there's 2 for each cylinder. One of them is going to control the intake valve and one of them is going to control the exhaust valves. Where the heck is the cam? All right, so for most modern cars, it's up on top of the head. It's sitting up here in the top end and driven by a belt. So the crankshaft is turning that thing with a belt usually, or chain. But this is kind of old school, and this one is actually inside the block. So it kind of just goes in this hole right here. So it's not far from the crankshaft. So folks, what we have here is the camshaft. All right, behind this big gear is the cam. Now, this smaller gear is the crankshaft, which is driving the cam by this timing chain. Now, why is the camshaft gear so much bigger than the crankshaft gear? Because the crank and the camshafts are working in concert during the power cycle. But the crankshaft needs to turn 2 complete revolutions during the power cycle, because the piston needs to travel up the cylinder twice to complete its 4 strokes. Whereas during the power cycle, the camshaft only needs to turn 1 time. It needs to open and shut the intake and exhaust valves. So in order to make this crystal clear, what I'm doing is I put a piece of tape with an arrow at 12 o'clock on the camshaft gear. So I'm going to turn the crankshaft now twice, and you're going to see very clearly that the camshaft gear is only going to turn once. 1, 2. So imagine this camshaft is being turned by the crankshaft inside the engine block. Those cams, those oblong shaped things, they're what's causing the valves to open and shut. How do we transmit that cam bump all the way up to the valve? Because it's got to go up, over, and down. Well, first, step 1, you have the lifter. The lifter or cam follower, or it's called a tappet. So this is a flat tappet. It's flat on the bottom, and that's what's actually resting on the cam as it spins and being pushed up. Now, the modern ones are usually a roller that's rolling around the cam. So you have flat tappet cams and roller cams. So this little lifter, we know it's got to be inside the block. That's where the cam is. It's buried in there. So how do we get it down in there where it rests on top of the cam? Through these holes. You see those holes back there. That's where the lifters are inserted, and they ride on top of the cam. So they just got to be kind of dropped in. And they're not really fastened or secured in any way. They just kind of sit there and ride along the cam. And as you're going to see, we have a push rod that sits on top of it. So now, what is sitting in that little cup on top of the lifter, which is riding along the cam lobe, is this push rod. This is transmitting that upward and downward motion all the way up to the rocker arm. So that is the push rod right there, sticking up. So in that same hole I showed you before, resting on top of the lifter that I dropped down in there. And what's interesting about this is it has a hole running down the middle. And you can actually blow air through this thing. So why is there a hole running down the push rod? Because it's picking up oil from that lifter cup. And that pressure of the oil pump is creating oil pressure, like 60 plus pounds of oil pressure in a healthy motor, and pushing it up. and it's coming up through a little hole in this, what's called the rocker arm. And this whole little cup right here on top of the rocker arm fills up with oil, which then drains down all over the valve and the spring and coats them. They need to be continuously cooled because remember, they're moving at incredible rates of speed. So here's one of the valves with its valve spring. This is what you see sticking out of the top of the engine right there. It's got a little retainer keeper thing around it of metal, but yeah, that's just a spring inside there, and sticking up out of the head. And the remember, they got the camshaft turning with the lobes, and it's pushing up the little lifter when the bump comes around, a little lobe, and the push rod sticking in that little cup, and the push rod goes up and pushes into the rocker arm, which pivots and pushes down on the valve. The rocker arm rocks and pushes down right on that top of the valve. Now this valve spring is going to be compressed, obviously, by the force of that cam and all that linkage, getting it all the way to this point right here. But the spring is going to shut the valve as soon as the cam lobe turns. Okay, so we're going to see the operation now of the valve train. So here's my rocker arms. This is my intake, controlling the intake valve. This is controlling the exhaust valve. We're about to start the intake stroke. So you're going to see this compress that spring and push that valve down. Intake. Exhaust. Exhaust. Intake. Exhaust. Intake. Exhaust. Intake. Exhaust. Intake. Exhaust. Intake. Exhaust. Intake. One more quick word about these valves. So here's the valve I took out of this engine, and this is where it seats in the head, and this is very important. If this wears down, then you'll have a lack of compression. You'll lose compression around the rings of the piston if they're worn out. And also this valve seal, where it seals and seats against that head, has to be sweet, nice and sweet. Here's one that's been kind of machined back to life. So that's what a valve job is. You basically go in there and reseat these things or lap them against, spin them, and get them to seat. Put this like lapping paste around here, and after they've been machined, you drop them in there and you make that bond nice and sweet, that seal between the head and the valve. You know, nowadays there's a lot of 4-valve engines, so each cylinder is going to have 4 valves. You know, we're learning little by little. Kind of old school is 2 valves, intake and exhaust. Now, however, we've learned that you can get better airflow, better efficiency if you can pack 4 valves inside of each little cylinder head. So it's important to at least be familiar with this term firing order. That refers to the sequence that the spark is delivered to each one of these cylinders, because not all of them are going to be on their power stroke at the same time. They're all going to be on a different stroke within the power cycle. There are 4 strokes, and in this 4-cylinder engine, each of them is going to be on a different stroke. So basically the distributor is stuck in there and powered by a gear that's around the middle of the camshaft, and that's going to stick in there. And basically what's left of this distributor cap, you're going to have spark plug wires going to each one of those spark plugs and sending them at just the right moment to fire that cylinder and ignite that combustion in that cylinder at the proper moment. So the timing of that is critical. You cannot cross these wires. It all has to work perfectly. So the firing order on this motor, every motor might be different. This one fires in the first cylinder, then jumps to the third, and then the fourth, and then the second. So it fires in that order. That's its firing order, 1, 3, 4, 2. So 1 fires, power stroke, boom, then the third one, boom, fourth one, and then the second one, 1, 3, 4, 2. Hope that makes sense. We've all heard that expression, so-and-so blew a gasket. Well, here's one gasket in the engine you do not want to blow, the head gasket. Okay. This is in between the top end and the bottom end, the head and the block. So there's a lot of violent stuff happening in there. There's oil going through these holes. There's water traveling through these holes. Inside these big holes, we already talked about the incredible violent activity, combustion, compression, all sorts of things, hot gases, and all that's so very close together within a centimeter, a half of a centimeter from each other. So critical part of your engine. So let's talk about how an engine breathes. It inhales and exhales through the intake and the exhaust. And let's talk about its inhaling first. It takes that air in through this intake manifold, which has an air breather or filter mounted to it, and it's going to mate up to the side of the head like that. And each of these runners, we call them, is going to deliver that air through the head and to the combustion chamber. So what can we do to add performance to this side of the breathing, the inhaling side? Well, we can get a better flowing intake manifold, better flowing intake, or we can port and polish what we have, so we can have our head and our intake polished by somebody where they actually take a grinder and they remove material in there to increase the performance, so that the air travels more smoothly through the intake and the head to get to that combustion chamber faster, more efficient, more smoothly. You can also try to cool your air down through a cold air intake, where you're actually able to pack more air in that combustion chamber, because when air heats up, it expands. So you want it as cool as possible when it enters the combustion chamber, so you can use a cold air intake for that. So what can we do to help our car breathe better on the exhaust side, to exhale those spent gases out the back of the car as efficiently and smoothly as possible? Well, we can use headers instead of the exhaust manifold that came from the factory, or long tube headers, even better. We can use a high flowing catalytic converter. We can get a higher performing muffler that's going to have better flow. We can actually change the pipe so that when you go to a regular exhaust shop, or when your car comes from the factory, the bends add a restriction to the path of the exhaust, because every one of those bends deforms the metal, because when they bend it, it shrinks right at the bend. So that slows the air down. It's not able to get through there as fast. Now you can get high-end exhaust system in there that's going to have mandrel bending, which is where they take the stainless steel pipe and they add this rod or tube in the inside, and the way they bend it with this machine, it remains symmetrical in diameter all the way around the bend. It's perfectly round, and there's no restriction to the airflow. So we call an engine that's just breathing normally, taking in the surrounding air normally through its air breather or filter, that's called normally aspirated. So you and I are breathing normally right now. We're aspirating, and we're normally aspirating. Now, what if at night you use a CPAP machine where you have this pressurized column of air going through your airways to increase your oxygen levels, and you're packing more air into your lungs? That's what some people need to get proper rest. Well, you can add horsepower to an engine by forcing more air in that combustion chamber. We call that forced induction. And along with that air, forced air in there, you're going to have more fuel as well. So you're just going to have more compression and more fuel and air in there, and it's going to translate to drastic improvements in horsepower. Adding forced induction is the most dramatic thing you can do to increase horsepower in a car, typically. So you have two different ways to do that, both of which use a compressor. They compress the air, but one is driven by the engine itself, by a belt that's driven by the crankshaft, and we call that a supercharger. And it's going to draw some horsepower away from the motor, but it's also going to add instantaneous horsepower as soon as you mash the pedal because it's working with the engine crankshaft. Then there's the turbo. Now a turbo takes the exhaust gases, and when they're collected together, gathered together, they're sent through this turbine, which spools up and powers a compressor and sends that compressed air into the cylinder. It has to be cooled off, typically through an intercooler, but you take that cooled down compressed air and pack it in there, serious horsepower. Now, the only problem with that is you have varying degrees depending on the size of the turbo. You have turbo lag because you have to wait until the RPMs get up into a certain power band. You have to wait for that turbine to spool up. So usually the power comes on a little later. There's a little lag time to some extent. And whereas a supercharger is not like that. It's driven by the crankshaft and it provides immediate torque and horsepower to that engine. That's pretty much it. Here goes. I want to talk about carburetors versus the modern ECU, which is an onboard computer. A little computer about that big, sits under the dashboard usually. So in the old days, you would control the air and the fuel mixture by the carburetor that would sit on top of the intake. But now, by the early 80s, they were tapering off, and by the early 90s, they were gone. So anyway, now we have what's called an ECU, or electronic control unit, or ECM, electronic control module, or PCM, powertrain control module. Basically, it's just an engine management system, an onboard computer that controls the air and fuel mixture. How does it do that? Well, electronic fuel injection, EFI motors versus the old carbureted motors. Now everything is EFI, electronically. The fuel is injected electronically by a fuel injector. Now in the beginning, we were putting them inside the intake, so they would be in these little ports, right inside the runner before it actually goes into the cylinder. We call that port injection or multi-port injection. But then we found out in more recent years that we can directly inject the fuel into the cylinder, direct injection. In the world of EFI motors, electronic fuel injection, that's being controlled by this ECU, electronic control unit. So you can actually tune that to add more efficiency, more performance. So basically you can get either a physical chip that you put into the computer, or you can have it flashed to change the software programming for the air-fuel mixture, or you can actually get your own self-tuning, do-it-yourself ECU, like Mega Squirt is a common one where you put that in your car and then you can hook your laptop up to it and tune your car yourself. So folks, I hope you persevered all the way through this. Thank you if you did, and there's tons more information and better videos out there than this one, but I had fun making this, and I hope you enjoyed it. God bless you.